Hi. Now, in the last video, we talked a lot about angles. And for most of that, we just set up the basics. Now it's time to go further. But let me start with something that isn't an angle whatsoever. A circle. Now, when we talked about degrees, I said that in a circle, they were 360 degrees. And so, if I was trying to represent a circular angle, I'd say that this was 360 degrees, right? And any portion of the circle, right, this angle, or this angle, or this angle, would all be less than 360, right? 360 is kind of the upper limit. Now, building on that, you might ask, what happens if I take my circle and I cut it in half? What angle is that? What angle do I make when I have a straight line? Do I make an angle at all? Because the angles we've seen have defining characteristics. They have one point here, a vertex, and another point. We say the angle is this between the two sides, right? That's how we form an angle. Well, this doesn't have a vertex. It doesn't have a meeting point where two different lines collide. Is this an angle? Yes, it is. And this has a measurement of 180 degrees. Why is that? Well, remember the circle we just drew, 360 degrees. We're basically taking a line through that and cutting it in half. Now, 180 turns out to be half of 360, right? So we can call this half angle, or flat angle, or whatever you want to call it. Basically, when you see a flat line, you know that's basically equal to 180 degrees. Now, here's where things get interesting. You might say, oh, this is all obvious. This is silly. Why would I need to know about that? And why is this the first thing we're talking about when we talk about angles? Well, we have our line. What if we do this? And I'm going to label these points just so we can make it easier. This is A, B, C, D. You might not see it at first, but I've actually just created two angles. Angle ABC, this angle right here, and angle CBD, this angle right here. And now, let's use what we learned about this flat angle to make an equation. So I know that this flat line is equal to 180 degrees. We don't know anything about the measurements of these two angles. But we know that if we were to take away this line, we'd have one angle which was 180 degrees. So going from that, we can say these two angles, if I combine them, must be the same as this one angle, this flat line. So these two combined, ABC plus CBD, must be the same thing as this flat angle ABD. What is this flat angle ABD? Well, we already figured out that it's half of 360. So this is all equal to 180 degrees. Now these are what we call supplementary angles. And it's a long way for saying that when combined, they equal 180 degrees. How do we know that? Well, there's always a flat angle, right? This is a nice little trick you can use in problem solving. If you're given two angles like this, and let's say you know the measurement of one. Let's say I know that this was 60, right? And they say, what is the measurement of this one? You might say, well, I don't know. But you look and you say, hey, this right here is a flat angle. And these two combined make that flat angle. So 60 plus whatever this is has to equal 180, which means this has to equal 120. So it's problem solving. We look for angles that we know work. We know this is 180. And then kind of construct a semi-algebraic equation to find this other angle. Now, supplementary angles aren't the only type of angles that we can do this relationship from. Let's say I have nice and simple angle A, B, C. And it is a right angle too. And we know from our definitions that a right angle has 90 degrees. What if I were to draw a line through that right angle? Look at that, D. Well, once again, by drawing this line, we created two new angles. Angle ABD and angle DBC. But once again, we notice if we were to take this line away, if we were to take these two angles and eliminate that line between them, we'd still be left with our original angle, which we know is a right angle, which we know is 90 degrees. So these two angles added together have to equal 90 degrees. We call these complementary angles. That, when combined, add up to 90 degrees. Once again, this is great for problem solving. If you ever see a right angle with two angles combined, use that instantly, right? Because once you know the value of one, you can very easily know the value of the other, right? If this is 60, well, 60 plus whatever measurement this is has to equal 90. So in order for these two to add up to 90, this has to be 30. And just by that, just by seeing that right angle, you've solved whatever problem you're presented here. That's how powerful this trick is. But what if we don't have a nice, easy relationship we can use? What if we don't instantly see a flat angle or a right angle? Well, there's still hope. We can still solve these types of problems by noticing relationships between two angles. I'll show you how. Let's say I have a funky angle like this. This is A, B, C, and D. Now you might say, this doesn't look like an angle. And you're right, it's not. It's actually two angles. Angle ABC and angle CBD. We call these adjacent angles. They're basically next to each other. They share a common vertex, B. Notice they both have B in the center. And they share a common side, BC. In this case, BC. In this case, CB. And adjacent angles share that little vertex, that point where they meet, and they share one side. They're neighbors. They're buddies. Now you might say, how does this help us? Well, let me give you an example problem. Say you were given this little diagram, and they told you the measure of ABC is 45 degrees. The measure of angle ABD is 120 degrees. What is the measure of angle CBD? Now, you might be wondering, what do I do? Or you might be wondering, well, there are two angles here. Where did this other angle come from? We have to look closely for this one. We have to do some sort of geometry in our heads. Just like those other problems, if we took away a line, we'd be left with a single angle. The same property works here. If I were to take away this line CB, I'd be left with a single angle, A, B, D. And I know the problem told me that this angle is 120 degrees. So how can we use this? Well, we know that since these two angles make up this single angle, that ABC plus CBD has to be equal to the measure of angle ABD. Well, I know this is 120, and that this is 45. We have an old algebra equation. Just subtract 45, and we're left with 75. I'll put it up here so you can see it. Sorry. $75. And this is why adjacent angles and all those other rules are so important. We can use these properties to take a problem in the wild and sort of break it down and say, okay, well, these may be two adjacent angles, but they're also one big angle, right? These may be two angles, but they're actually one 90-degree angle or one 180-degree angle. And we can construct algebraic equations by saying, oh, they must add up to be 90, or they must add up to be 180, or in this case, they have to add up to be 120 to solve problems that, without that understanding, we couldn't. So that's why these types of relationships are important. And we're going to use these types of relationships to discover even more relationships, including your first mathematical proof. That's next video. That's right. You guys are going to prove it. All right? So stick around, because next video is going to be particularly fun. But that's all I have for this video. Just to recap, supplementary, 180, complementary, 90 degrees, adjacent, common vertex, common side. That's all I have, and I hope you guys have a great day. Thanks for watching.